team number 4, and we are presenting quadratic surfaces, geometric objects in 3 dimensions, and their curves. As you can see, we have the exercise my partner Juan Pablo Bailon was solving. As next, we will show you the representation in GeoGebra. Okay, here we have GeoGebra. We will write the exercise right here. That is x plus 3 squared over 9 plus g plus 4 squared over 16 plus c plus z squared over 4 is equal to 1. Okay, here we have the hyperboloid. Now let's see the different forms that conform this equation or this form. So to set a variable equal to 0, we need to remove it from the equation. Okay. Okay. As first, we're gonna remove the x variable. And remember, the equations need to be always equal to a value to 1. Okay. Here we have that when we eliminate the x variable, we have 2 hyperbolas extending on the axis x. This is the first shape. Then let's do the same, but with the g variable. We need to eliminate this and equal to 1. And as saying the same, we have 2 hyperbolas extending on the axis g. Okay. Finally, we are going to eliminate the last variable, that is c equal 1. And we have a different shape. In this case, we have an ellipse that extends on the axis C. And these three shapes form our hyperbola of hyperboloid. Excuse me. To see the difference, let's change the color, and we have the hyperboloid on color blue, and the different forms with red. As next, my partner Martín Cital is going to show you how to represent the curves of the same exercise.
Okay, Good afternoon, teacher. I'll explain to the level curves. In this case, one left, one left. mm, I'll I have to the level curves in the before equation. Can you support me, partner Kevin, mm, to take a board, please? Good afternoon, teacher. Today I will explain about the level curves. In this case, it will be from the previous exercise of uh, one leaf by my partners Eliza and Pablo. Well, to determine the level curves, it's necessary to know the formula, which is that the x and y is equal to c, and c is equal to a constant. What is a constant? The constant is some number, uh, somewhere number. It's represent for letter K. Letter K represent a constant. Okay. This don't need a to the plane to be able to observe the increase of the hyperbolas in revolution. For example, we have a plane X and Y. Uh, the first level curve is X and Y equal to 1. For example, the level curve is here because the center is 0 for 0 and the level curve is equal to 1. It passed to the number 1 in X, number 1 and less Y, number 1 and less X, and number 1 and J. Okay, knowing this, we go to algebra. I share my screen. Wait me. Okay, switch calculator algebra. Share. Can you tell me? Can you see my screen, my partners?
Yeah.
Oh, thank you. Okay. I mean, where we will use the equation shown above. However, we will be giving a value to c, a constant, which can be any number. Okay. The formula I copy and paste for the save time. And this is this formula. To start a graphing, I will copy the formula of the equation from the previous exercise. Okay. I will eliminate the sign. That's right. And I will equal to some number. For example, the number 3 is a level curve, and with the same formula, same equation to another level curve with the constant. It's number 2. And successfully number, I don't know, number 4, number 1. Well, as can be assumed, we have different hyperbolas around the previously determined center. Like my center is equal to 0, and it's identified in this point. The center, the hyperboloid, and it's if constant are put, will resemble the revolution that are made to create a hyperboloid. And this is all for the level curves. Now my partner Kevin Sánchez will explain an exercise on a hyperboloid with two lifts.
Following is place size is about to left hyperboloid. Then I will write the equation. Less at less 2 square over 9 plus j four square over 16 less c less 6 square over 25 equal 1. We can calculate and the centers, the square root, and those numbers. A square root for 9, B square root 16, C square root 25. Equal 3, 4, and 5. The center center is 3, 4, and 5. Then the second step is the calculate intersections in the axis x, y, and z. The calculate the formula is eliminate h one axis. Y less 4 square over 16 less c less 6 square over 25 equal 1. The next is less x 2 square over and 9 less and c less 6 square over and 25 equal 1. And then it is x less 2 square over 9 plus a 4 square over 16 equal 1. The next is will representing in the algebra. The next will request script there. Well, less x less 4 square over 9 plus plus y less 4 square over 60 less c less 6 square over 25 equal 1. Eliminate the variable at the equation. A y square square over 60 less c less 6 square over and 25 equal 1. The next is eliminate the variable y. And is x less 2 square over 9. Less c less 6 square over 25 equal 1. The next is finish eliminate the variable c. X less 2 square over 9 plus y less 4 square over 60 equal 1. Change the colors that shows with the next my partner Jair Camacho.
Good afternoon, teacher. Um, I I will do a exercise to hyperboloid the two leaves. So, all right. Okay, the exercise is less x squared under 9 plus y squared over 16 less c squared over 4 equal 1. All right. The general formula is x squared over a squared plus y squared over b squared is less and less c squared over t squared equal 1. All right. Yes. Okay. The general formula indicate that only one variable is positive. Okay, when we talk about the two-leaf hyperboloid. Okay, so the first step is have an a, b, and c without the square. So we have a 9, 16, and 4, right? And this is the square root of 9 is 3. The square root of 16 is 4, and the square root of 4 is 2. Okay, but the x, y, and z is that indicates the axis. Okay, in this case, we have the x is 0, the y is 0, and the z is 0. So our center is in the point 0 of the graphic. Okay, and but now for now the axis, we begin to the x. Okay, so x and less x squared over 9. Okay, and the x squared is less 1, so we use the square root, and it's the square root of less 1 multiplied to 9. So the result not exist. So how we have a square root negative, we not have any result. So the axis is 0. And in the case of y, if y is a positive variable, so is the same procediment. And right, is y squared over 16. So it's equal, y squared is 1. So the square root of 1 multiplied of 16 is equal 4. Okay, we have a 4. The 4 can be positive or negative in the graphic. Okay, and in the case of the axis C, is the same procediment of x, and because it's a negative, it's a negative variable, so the result is the same. The result is 0. All right, so it is we number. I will show in the graphic. Yes. So here we have less x squared over 9 plus y squared over 16 less c squared over 4 is equal 1. So we have our hyperboloid. So we have less 4 is used here and plus 4 in the axis y. So in the axis c and the axis x are 0. So we not have intersection with the trace axis because it's in the center. Okay, in this case y is equal 4 and y is equal less 4. Okay, that we can change the color of the two leaves that are used here right when begin the hyperboloid. Less 4 and plus 4. Right, and it is everything for the hyperboloid of two leaves.
In conclusion, we can determine that hyperbole is a surface of revolution generated by hyperbole in rotation around one of its two axes. Finally, as can be seen in the formulas presented above, they are very similar, however, with a real problem. And to determine the what is the how is the leaves is the for the sign. If the sign is positive, one sign is positive is a two leaf. If the sign is if this one sign is negative, it's one leaf. It's all. Thank you for your attention, teacher.